Number 5, we've got parametric equations given here, and we want to find the equation of a line tangent to the curve that they trace out when t is 1. So to write the equation of a line, I need a point that the line passes through. Well, I can get that by plugging the 1 in. So the point is going to be x equal 1 minus 3, which is negative 2, and y equal 2 minus 0. Natural log of 1 is 0, so this is just going to be 2. So the point that's on the graph, this is actually the point of tangency in terms of x and y, is minus 2, 2. And then to write the equation, I also need the slope. So the slope, we know that's going to be my derivative evaluated when t is 1. And so remember, the derivative is the derivative of y, that's this, 2t minus natural log t, divided by the derivative with respect to t of x, that's the derivative of t squared minus 3t, and then I'll evaluate that when t is 1. So let's see, I'm going to have derivative here is 2 minus 1 over t, and in the bottom, the derivative is going to be 2t minus 3. And I will plug in 1 and get 2 minus 1 in the top. In the bottom, I'll get 2 minus 3. So the slope is minus 1. So the equation is y minus the y coordinate, which is y minus 2, equals the slope of negative 1 times x minus the x coordinate. And then I can rearrange this if I need to. Anyway, I get y equal minus x. This will be a positive 2, but then it becomes a minus 2, and I'll bring over a 2, so it looks like I'm just going to get y equal minus x, assuming I did all that right. Okay, and then it says find the values where the parametric curve has horizontal tangent lines and where it has vertical tangent lines. So we know that horizontal are going to come from when dy dt equals 0, and we did dy dt above. It was this one, the numerator. So that's where that thing is equal to 0. And so I'll clear out the fraction by multiplying through by t and get 2t minus 1 equals 0. Solving, I get 2t equal 1 or t equal 1/2. So that's a potential place to where I could have a horizontal tangent. So this is for horizontal. And then for the vertical tangent, potentially where those will occur is when the denominator, the derivative of the denominator is 0, and that's the derivative right here. 2t minus 3 equals 0. And so that's going to give me 2t equal 3, which would be t equal 3/2. And since these are both different, meaning there's no overlap where I have something in both options here, then these are the cases. This is where I'll get a vertical tangent, and this is where I'll get a horizontal tangent if I were to sketch the graph. This one asks me to find the area under the parametric curve given by this on the interval 1 to 2. And so we just have to remember that area in general, we think of integrating on some interval a to b. These are intervals x equal a, x equal b. We integrate some function y with respect to x. And so in this case, we just plug in what we have. We're integrating with respect to t, so we're changing to our parameters. Our parameter of t, this interval, is being changed so that I end up with y is 2t squared plus t, and dx is going to be the derivative of natural log of t, which is, so dx will equal the derivative of natural log of t dt. Well, that's going to be 1 over t dt. And so I just finished this integral. I'll multiply through by this 1 over t to get 1 to 2. Just knocks these powers down and get 2t plus 1. And so integrating that, I get t squared over 2. So this 2's will cancel, so I'll get t squared plus t, and I evaluate that from 1 to 2. That's going to be 4 plus 2 minus 1 minus 1. So what is that? It's 4.